Okay, it's always funny when people get these kinds of things wrong because it's really, really easy, but I think it's just that people don't use scatter plots very often in their math classes in school, or maybe they've just never had them explained. And so let's just do that, and then you will never get this question wrong again. So the scatter plot shows the relationship between the two variables, x and y. Great, that's not new. A line of best fit is also shown. For how many of the 11 data points does the line of best fit predict a greater y value than the actual y value? Okay, so the key thing here is that we need to know the difference between the dots and the line. And sometimes it's a curve, right? So we all often have a line of best fit, but it could be a curve of best fit. Just it's the same thing, right? So the dots, those are our actual values, right? So in this case, let's say this was like a survey. We were measuring like the shoe sizes of a bunch of kids. Well, the dots would represent the actual kids and maybe their ages to go along with that, right? So you would see that like there is a real person who has, let's say, a shoe size of whatever this is, right? So 7.5 and is 9 years old, right? Like I don't even know if that makes sense, but you get my point, right? Like there's a person there who represents that dot. But when we have the line of best fit, what we're trying to do is make some sort of bigger prediction. So the line of best fit is basically filling in the gaps. It is a mathematical way of connecting the dots, right? It's not literally connecting them by drawing a line between them, but it is mathematically connecting them and finding that overall pattern. So it fills in the gaps where we don't have someone of a certain age. It fills in the gaps where we don't have a certain shoe size, right? So it's giving us that overall trend. And yes, some of the dots will be on that line, but lots of them are going to be above it. Lots of them are going to be below it. And it's okay. It's just usually when these questions involve scatter plots, we don't actually care about the dots at all. They're usually a distraction. It's usually the line that we're being asked to make an equation of or something like that. So in those cases, don't worry about the dots. Just focus on the line. Here, though, they're literally asking us to compare them. So how many of the 11 data points does the line of best fit predict a greater y value? So the line is greater than the actual dot, right? So we're looking, where is the line above the dot, right? Because y is the y-axis. So I already circled 1, 2, 3, 4, 5, 6. So notice for all of those dots, if I just kind of like look, the line is above the dot, right? We're not going left and right. We're going up and down because they're talking about the y value. Y is up and down. So there are 6 dots where the prediction is greater than the actual value, okay? It doesn't, I don't know if that's good or bad. It doesn't mean anything to me. It's just, that's just what this means, right? So there's your 6, that's the answer, and we're done. So hopefully if you did get this wrong, it was just because you were like, I don't even know what they're asking. This sounds very complicated. But scatter plots are not that complicated. It's just you don't get a lot of experience with them. And I think that's why the SAT really likes them. But just get used to them. This is about it, guys. It's the knowing the difference between the dots and the lines. And usually we're only interested in the line anyway, so you can mostly ignore the dots. But here, hopefully understand why we're looking at both.